Hey you guys, here I'm going to kind of visualize a little bit of what it means to do the double allocation. Here I have a snippet of code from our last video. We have mat1, which is a matrix that is going to have 2 rows and 2 columns. So first with mat data, I do a malloc, cast it as a double pointer to a double data type. And here I'm going to allocate mat.row, which is 2 pointers to a double. And this is what it looks like. So we can think of this as an array of two pointers that point to a double. Right? This is the first one, and this is casted as a double pointer, meaning that since this is a double pointer, the value of a double pointer is a pointer. So let's move on to the next loop. So here what I'm doing is that I go into mat1 data plus I, and since this is an array, it first starts as 0. So 0, right, we're here. So when I dereference that, the data type here is a pointer to a double. So here's where I can do the standard allocation where I do mat1.call times the size of double, which is 5. So here now, this is going to have an address that points to 5 double values, right? So we can think of this as the first row with 5 columns of our 2-dimensional matrix. Next, when this iterates and I is equal to 1, mat1.data plus 1 is going to be this variable right here. And here we're going to do the normal malloc. So this has a value which is a pointer to a double. And I do malloc. Again, mat1.call is going to be 5 values, 5 times the size of double. So here I allocate 5 doubles. And this is going to be the second row, again with 5 columns that belong to my matrix. So I essentially create a 2 by 5 matrix, and this is kind of like the visualization of what's going on with the code. So now let's get back to the code. So now that I have the creation of the data and I allocate memory for it, especially with lines 13 through 16, and then I'm safely able to free it with lines 18 through 21, now I have kind of like a usable matrix. But this is data that does not have initial values for it. So I think I should create a function where I can pass it the matrix that I want to initialize it and the value that I can initialize it to. So why don't I go about, I'm going to call it init mat. I don't know what arguments I'm going to have there right now, so let's comment it out and let's save. And we'll edit my mat.h. So here what I want to do is that, I want to have a function that will initialize my matrix. It'll be void init mat. Well, I'm doing it because since I'm dealing with dynamic memory, I need to use what I have, right? The structure here, the struct mat, it has the data attribute, which is a double pointer to a double, and that has dynamically allocated memory. I don't want to recreate a struct mat if I don't have to. So what I'll do is that I'll get a reference to the mat in main, and I'll edit it here, and I won't have to change it in main. So how that will work is that I'll have matrix mat, and you know what? I want to give it a second argument called value, where all the values, this value, which is cleverly called value, this double variable will be put into every single item that's been allocated in data inside of mat. So here's going to be the declaration of the function in the header file. Now what I need to do is that I need to create a file with the C programming that I need, which I'll call mat.c. This will include my mat.h, so that way we have access to the structure and the function prototype. I'll copy this here, and what I'll do here is that I'll have two iterators, I and j. I'll have my for loop, and this will iterate throughout the entire matrix, and now I need to give it a value, a way about getting values. So here's how I will need to do it. Well, first I want to access the data of mat. Since mat's a pointer, I need to dereference it. So data. Okay, so mat arrow data. What's data here now? Well, here now I just have normal access to data, right? And if we go up here, now I'm dealing with a double pointer. Shoot. Well, one way that I can go about dereferencing this now is that I can do this, and I want to add I, but that's not enough. Actually need to, well, this will let me access the first dimension, which is the two rows, which is good, but now I need to access the columns. So I will need to do another wraparound and dereference it again. Oh man, this is starting to get messy, but this is good. This is what I want to do, because here we have a pointer to a matrix. Since this is a pointer to a matrix and I just want to access the matrix itself, I need to do a dereference. And because I want to access data specifically, here I take mat, which is a pointer to a matrix, and I dereference it, which just turns it from a pointer to a matrix to just a plain matrix, and then I use the arrow to access data. Okay, so what's data now? Well, data is a double pointer to a double. Okay, so since I can use that as the first dimension of the matrix, well, here I'm going to dereference and add I. So this statement all itself I can use as accessing the row of the matrix, but I need to take it a step further. I can't just access the rows, I also need to access the columns. So I need to add another layer of dereference to access the columns, and this is how I do so. And I simply want to equate everything to value. And because this is a pointer and this is passed by reference, whatever I do to mat here will affect mat1 in main. So this is a pretty good place to start. So now let's go back to editing main. So way down here I'm going to call init mat. Now that some of the logistics behind the function are good now, I know what to put for its arguments. The address of mat1, and let's give it a value of 2. We're going to set the entire matrix to 2. So it'll be a 2 by 5 matrix, all containing 2 values. Well, if that's the case, how will I find out the values of this matrix? I should probably create a print mat function, so that way I can print the contents of the matrix. This will be done in the next video. Thanks for watching, and I'll see you there.